Okay, pre-calculus, here's the deal. Since I'm gone and your job is to do lesson 7-1 over the weekend, have it done by Monday, so you and Mr. Glaser can correct this. Let's just quickly go over it. You're going to probably like Chapter 7 mainly because it's just a repeat of Algebra 1 and a little bit of Algebra 2. So let's get started. We are solving systems. Okay, solving systems of equations. If you remember what it was two equations, usually linear. I'll just put 2x plus 5 equals y, and maybe y equals 10x minus 1. Your job is to come up with the common solution. Okay, the common solution that works in both. Has to work in both equations to be a solution. How did we do it? Well, we did it by substitution and graphing, but mostly substitution is where we're going in this assignment. Your graphing, I believe, a lot of it is on the graphing calculator. All right, so let's get started. Here we go. The first problem, take the graph paper that I gave you. Use graph paper to graph each equation by hand. Using this graph paper, estimate the solutions. They're both linear, so I would probably solve for y on both of them. First one you get y equals x. Second one you would get negative 3y equals negative 5x plus 6. Okay, divide by negative 3, answer positive 5/3 x minus 2. Okay, your two equations in slope-intercept form are, as you see, I guess, y equals x and y equals 5/3 x minus 2. Okay, if I graph y equals x, it starts at 0, 0, has a slope of 1. So there it is. Connect your points, draw your line. If I start, okay, the other line starts at negative 2, okay, right about here, has a slope of 5/3, so up 1, 2, 3, 4, 5, up to there, and 3 to the right would put me right there, and there's the line cutting through. Okay, the common solution. The point they share happens to be, looks like 3, 3. So in this problem, because it's linear, two lines, in this case, two lines met in one point, so there's one solution. Remember back in Algebra 1, there was a situation where you had this. Two lines are parallel, don't touch. We said what? No solution. Okay? There was another one where you had one linear line like that. The other line fell right on top of it, so they touched everywhere. This is the one where you said infinitely many solutions. Okay? So there's another couple cases of linear systems right there. But for the most part, you're going to get solutions. There's your solution, 3, 3. Next slide. Okay, this one, use your graphing calculator to find the solutions. Well, I hope you can see x to the first, y to the first. That would be linear. This is y equals x cubed. Cube is cubic. Now remember, cubic functions can do funny things. They can do this, or they can do this. They can turn once, twice. Or in the first one, they didn't turn at all. So you've got a few things, a few options for cubic. But the nice thing is the calculator will help you on this. And I think you have 2 problems in your assignment, so you might have to save them for Monday. Anyways, so here's what I did. I typed them in already. I'll show you what I typed in. I've got 2x minus 5 for equation 1, x cubed minus 3x minus 1 for equation 2. And now I want to graph them. So I'm going to remind you to hit zoom 6 And that will get you a picture of 10, 10, 10, 10. All your dimensions are 10 by 10. Here comes the linear function. Here comes the cubic function. It's hard to tell how many solutions there are. There's one down in the far left corner. And there could be one, there could be two right in the middle where the blue and the red touch. For you to get these two or three answers, you're going to have to focus in really tight on where it looks like there could be two solutions. So I'm going to change my window, and I'm going to go like this. Change my window to x minimum 0, x maximum 2. And if you're wondering how I'm doing this, I've already done this, and I know what the answers are. That's why I'm doing it. You're going to have to play a little bit here. My y minimum, I think I'm going to go down to probably -5. My y maximum, I'm going to just go down to 0. I just want to see what this looks like. And now it really focuses in on the line. And here comes that cubic function. And I think just by showing you that, you can see there's two solutions there, plus the one other solution that if you remember. Okay, let me quick show you how to find the intersection point. Just hit second, calculate, hit number 5. There's number 5, it's the intersection point. And then if you look at my calculator, it says first curve. And now you just have to kind of get off that intersection point a little bit. So I'm on the linear function, and it says first curve. I hit enter. Then it says get to the second one, and it looks like I'm already flashing on the second one. But if it's not flashing, just hit your up or down arrow, and you should jump to the other curve. Hit enter. Then it says guess. Hit enter. And there it is. It looks like they intersect at 1, -3. Now you have to find the other intersection point. So you're going to have to hit second, calculate, 5 again, and then you slide over to the other one. So then you just repeat the whole thing again. You hit enter, you hit enter again, and then you hit enter again, and it tells you the next one is 1.56, comma, -1.888. Okay? And that's how you use your graphing calculator. Okay, let me quick write those answers down because you probably want those in your notes. If I were you, I'd probably draw a quick picture of what it did look like. It kind of went like this. There was a line cutting through like this. It was a cubic function going like this, and then this, and back up. So you see that you have an answer here, an answer here, an answer here. The three answers were -2.56, comma, -10.12, that's this one. And then there's +1, comma, -3. And then there's 1.56, comma, -1.88. Okay, so there's your three solutions for this one. And that's why you want to use your graphing calculator. All right, this one actually says go ahead, sketch it, and that's, sketch it by hand on graph paper. I hope you see already this one is linear, so this would just be y equals -x plus 4. That's pretty easy to graph. Start at 4, slope that's negative would be downhill. Here we go. Down 1, right 1, up 1, left 1, whichever way you want to go. Okay. And then this one, hopefully you recognize this from chapter 1. In chapter 1, x squared plus y squared equals r squared. That is the standard form of a circle. Center, 0, 0. Okay. The radius is r. Okay. Although you don't have that, you have x squared plus y minus 2 quantity squared. And you have to remember back to your transformations that y minus 2 means, it doesn't mean down to, it means up to. It's always the opposite of what you think. This x value, x squared, you don't go right, you don't go left. So really, the center of your circle did not go left or right, so it stays 0, but it went up 2. And this 9 is r squared. So if you want r, you got to take the square root of it. Square root of 9 is 3. Okay, so the radius is 3. So you're supposed to estimate these answers, and this is a very difficult problem to estimate. Center 0, 2, up 3, right 3, left 3, down 3. And there it is. Boom, just like that. All right, I think you can see there's 2 answers, and then I did the best I could to estimate these. I kind of just said solutions are, I think I did 3.75. I'm really guessing on this, and 1.5. Okay, I'm hoping I'm pretty close. That would be this one right here, right there. Okay, and the other one I guessed it out to be negative 1.7, no, 1.5, and I thought it looked like 4.5, and that will be this point right there. Okay. And I'm off, but it's okay. It's just an estimate, just trying to see where you graphed it. Okay. Last but not least, the substitution method. This is a method it's an algebraic method. You just solve for your variables. But if you remember, the substitution method said solve one of the equations, if it's not already solved, solve for either x or y. In a perfect situation, one of them's already solved for x or y, but this is not perfect. I'm looking at these two and I'm thinking, boy, it'd be easy to just solve for that y. Y equals 2x plus 5. And once you know what y equals, substitution says take what you know. I know y is 2x plus 5. Put it in for the other equation. Substitute it in. And then rewrite the other equation. X squared plus 3x minus what? Looks like 2x plus 5. 2x plus 5 equals 1. All right, quick solve for x, and then you've got your x values of the intersection point. X squared plus 3x, take away 2x, take away 5 equals 1. I hope you notice it's quadratic. Quadratic, get it in standard form. X squared plus 1x, take away, if I move the 1 over, it's 6. Solve that quadratic. You could use the formula, but don't use the formula. Always look first to factor, and this one is factorable. X plus 3, x minus 2. All right, coming out of these factors, when will x plus 3 be 0? When x is negative 3. When x is 2. Now, just so you know this, you get 2 x values, which means there's 2 solutions. Okay, 2 solutions, what are they? Well, one of them is negative 3 comma something and 2 comma something. Now to get your y values, just take your x values, this and this, and go back up to the one you solved for. Okay, so, okay, let's put it in. Y equals, well, one of the x values was negative 3. So that's going to be negative 6 plus 5, negative 1. There's one of them. The other one, I think it was 2, wasn't it? Yeah, I think so. Yep, 2. So if you put that one in, yeah, sure. The other y value is
This one is enough.
2 times 2 plus 5, which is 9. Okay, you have x, you have y. We're almost done. 2, 9 is a solution, and negative 3, negative 1 is a solution. And there you go, guys. That is the substitution method. One last thing, just so you know. The reason you're getting two solutions is because you've got a linear that matches up to a quadratic. If I actually graphed it, guys, it is basically a line like this, and it is a parabola. So it kind of goes like this. Okay, and if you look at it, there's that answer that we got. What was it again? 2,9, I think that's 2,9. And this answer is, I believe this answer was negative 3 comma negative 1. There you go. So that's why you got two answers. You had linear meets up with quadratic. Good luck. Get your assignment done. Have questions ready for Mr. Glasner on Monday. Have a good weekend.